In this video, we are going to focus on significant figures. Significant figures are how we're going to report a number and communicate our level of uncertainty about it at the same time. So defining them, significant figure is just the number of digits that are reported for a measurement. And so you would report all of the measurements that were actually reported or given or read from an instrument plus one estimated digit. And that estimated digit is really us using our own ability to observe either where a line is or reading a scale that might be changing a little bit and adding a level of interpretation there. So in general, the greater the number of significant figures, the greater the certainty of the measurement. So if I can report more digits to a number, I have a much more accurate tool for measuring that mass or that volume or that density. So to be able to accurately report significant figures, we need to be able to distinguish between two types of numbers: exact numbers and inexact numbers. So exact numbers will have an infinite amount of significant figures. They just go on forever. You don't have to report them all. And so examples of these would be counting objects. So I have 10 fingers and I can count them, and that's an exact number. I'm not going to be able to estimate that I have 10.1 fingers or 10.5 fingers. I could just say I have 10. Integral numbers that are also part of an equation are also going to be considered exact numbers, where we don't have to worry about the exact number of the number of digits that are reported for them. And then the other one, the one we'll use probably the most, is defined quantities. So this will include things like conversion factors. If I say there's 100 centimeters in each meter, I am defining 100 centimeters by another unit of measurement. And so this 100 and this 1 are going to be exact numbers in that definition. And so I won't care about the significant figures in that conversion factor. Now, inexact numbers will have significant figures that actually reflect the precision of an instrument that was used to take a measurement. And so these are always going to be measured values. So things like collected data from lab or data that's reported that you're using from someone else. That means that the nice way to differentiate between these two is that if our inexact numbers are measured, our exact numbers are typically given or definitions. So let's try reporting with correct significant figures, taking a measurement of volume. So I have a graduated cylinder here, and I have a, I'll try to make this a little bit darker. The volume of water here is coming up to this blue line. And I'm going to try to report this with the correct number of significant figures in a way that communicates the level of precision of this device. So I can say, I'm going to read from the bottom of the meniscus, which I'm highlighting right here. And to me, that looks like it's right on this second line coming up from 9. So I can read this one right here is 9.0. The next line is 9.1, and the line that my water is coming to is 9.2. So these represent the numbers that I can read from my instrument. And when I'm taking a measurement, I always give the numbers that are read from the instrument plus one estimated digit. Because this line might fall a little above or a little below that 9.2 marking. If it falls halfway in between the 9.2 and the 9.3 marking, I would say 9.25. I'm guessing where it is. Right now, it looks to me like it's right on that line. So the way that I communicate that I think the measurement is coming directly to the 9.2 line is by reporting it as 9.20, where 0 is my estimated digit. That means altogether, I'm going to report 3 significant figures. when I report the measurement of volume that I have right here.